Hey, what's up, guys? Chung here again. So this time I want to talk about this LeetCode problem here, number 850, rectangle area 2. It's a hard problem, and it's also a very classic. You can call it line sweeping or skyline problem. Basically, you're given like a list of rectangles with with two sets of the coordinates, right? The first set of coordinates represents the bottom left corner, and the second set of coordinates represent the top right corner. And since it's a rectangle with those two coordinates, we can locate the the size and the position of this rectangle, right? And then it asks you to the problem asks you to calculate the total area covered by all the rectangles. All right. So so as you guys can see here, so one thing is that if there's a, like overlapped, right? If some rectangles got overlapped with each others, for example, this one, the if this green rectangle is like 2 by 2, let's say if it's somewhere right here, right? And then we're gonna over calculate the area once, right? Because we don't want to the double calculating the same area more than one time, right? And okay, so with this kind of classic like line sweeping or the skyline problem, so a typical way of doing this is basically we scan the row column by column, right? Basically, we're gonna have like a line swiping from left to right. Okay, from left to right, right? And every time when we see like an ending point here, right? Every time we see the ending point here, we will be calculating. Okay, so we'll check how many like horizontal uh how many vertical segments we need to calculate, right? Because we since we're scanning from left to right, we know the horizontal width from the previous one to the current one, right? Let's say we scan from this 1 to 2, right? And we know, okay, so the current scan is we are scanning from 1 to 2, right? And we know the width is 1, right? And then all we need to know is that like how many segments from 1 to 2 we need to calculate, right? And because if we have that, and with each of the segments, we just need to I mean the segment, I means the segment vertically, right? So if we have all the segments we have from 1 to 2, from the range 1 to 2, then we can simply do those segments times the width from 1 to 2, right? Then we just add it to the current to the our final result. So and then the problem comes down to how can we maintain for each of the range, for each of the line sweeping from a previously location to the current locations, how can we maintain the the segments, right? The segments vertically, so that we know what are the segments are the candidates, right? And then we'll deal with the some overlapping of in that segment later on. So for that, we're gonna have like events. We will need to create like events uh, of two types of events, right? So the first type is the starting events. Basically, the starting events uh, is x, right? The location of starting events is x1, right? And the ending events rectangle, since we're scanning from left to right, right, is x2. Basically, this is the starting point, and this is the end point, right? And for each of the events, we're gonna not only we're gonna stores the the x coordinates will also be and will also be like storing the y coordinates, basically the start and stop y's. And every time, and then and then we're gonna loop through this starting events. So we're gonna sort this starting event from the smallest to the biggest. And every time when at the current y locations, if we see okay, if we see the event is a starting event, right? And then we're gonna add this y1 and y2 into like these intervals, okay? So basically, these intervals is going to be the ones when we try to calculate the area for the current range from 1 to 2. So we're going to maintaining these intervals for the current segment, right? So basically, the way we're maintaining these intervals list is every time when we see an open event or a start event, we uh we we insert this y1 and y2 into these intervals, and when we see like uh, a close event or end event, we remove these intervals from this internal intervals list here, right? So that's how we maintain this the current active intervals. We should be calculating its area, and yeah, basically that's the basic idea of this like line sweeping problem, and that's the first step. And the second step is once we have those intervals, right? How can we calculate the segments, right? That's going to be another problem because okay, so for the intervals here, let's say it's fixed, it's a fixed length here, right? From whatever the previous one to the current one, right? And now the problem comes down to let's say we have a bunch of like intervals in this here. It's although it's a vertically, right? For example, from this here to here from y1 and y2, right? This is one, and the other one is somewhere here, right? And then there could be like a nested like or overlapped any, right? So it could be as many as possible, right? So for those, how can we it's kind of like a merged intervals, right? Kind of like we have to merge the overlapped intervals with one, right? And then if it's a different one, we just add that. We just okay, we just make it calculate. Okay, we know this interval does not overlap with anything, so we just simply calculate the area of this single one. For those ones who got merged, right? Then we will basically try to handle them all together, right? And for that, right, the way we're also doing the merged intervals is we also sort. We also sort by y1 here, right? So that we can basically merge those intervals, right? So it's kind of like a nested line sweeping, right? Basically, we sweep from left to right, and then at each of the line sweeping process, we will also try to basically merge, right? Merge all those intervals within this current range, right? Okay, so okay, with that being said, let's try to code these things up. Okay. Okay, so and first the event, right? So first we're gonna have like events, uh, and for xy, x1, y1, x2, y2, right? Um, in rectangles, right? in rectangles, and events, right? Events append. So the first one is going to be the open event. So the open event is going to be starting from the x1 here, right? X1, and the type we use either 0 or 1 to represent if it's a open event or closed event. And then the y1, y2, right? Same thing here. Events append x2, 0, y1, and y2, right? And then like we said, we need to sort. Okay, let's just sort, and then we're gonna have like intervals, right? Intervals, and also the answer here equals to 0, right? And then since this one is already sorted by the first element, right? By the x by the x, so we can just slice these things, right? Like this, and then like this, right? And because this x1 and x2, since we're looping through everything, that can tell us all the start and end, possible start and end for all the rectangles, right? So that we can simply do a loop here, do a for um, for event, okay? For event in events, right? Or actually, we can just do a and it's going to be the current x, okay? Current x, and then the type, all right? Type, the event type, and the y1 and y2, okay? So and every time when we are at this new location here, right? First, we will be try to calculate, right? Basically, we're gonna have like a answer plus the area get area, okay? I'll just call it get area, and we'll implement this get area function later on. And then after that, right? After that, we're gonna try to update these intervals, right? And basically, okay, so since this y1 or y2 or type, we are either at the open event or the closed event, right? So basically, if the type equals to the equals to sorry, this is one, right? So this is gonna be the end event, right? This is the open event, the start event, okay? Start and end. If this thing equals to 1, then it's a close end event. So for the close event, we will be we're gonna do intervals dot remove, right? We're gonna remove this this segment, right, from the intervals. Else, right? Else we are into interval dot append, right? And since you were sorting by the start and end, so uh, there shouldn't be any case that we do for the same rectangles, right? We do a remove first, then the then the append, right? Because we sort by the start and end uh, locations, right? So we don't need to check if the interval is empty or not, because at this moment, whenever we try to do a remove, there has to be some intervals already in this intervals, right? So that's how we maintain these intervals, right? And then uh, and yeah, and another thing is that and to calculate the area, like we said, we have to get the from the previous one to the current one, we have to get the width, right? The width from the previous one to the current one, right? so that we're gonna have like a just use a previously x, okay? Uh, previous x equals to what's the value of that? The value is gonna be rectangles, the length. I just want to check how can we initialize this value here? The x1, x2, rectangles, x and y. Okay, so it says that rectangles x and y. Okay, so the value is a positive. So basically, there's no way it can be a negative number here. That's why we can just initialize with 0 here, right? Because the smallest of the x's will be 0, so we can start with 0, and then basically here, right? Basically here we just need to pass the difference, right, with the current x and the previously x, right? So that will give us the the width of the to calculate the current area, right? And we simply in the end we just update this pre-x, right, to the current x, right? In the end, we simply return the answer, okay? And okay, yeah. And since it says it's going to be a mod, equals 10 to the power of 9 plus 7, right? And here we simply do a answer mod, right? And now the question comes down to how can we, okay, so with this maintained current active, you can call it current active intervals, right? From the range current x to the previous x, how can we calculate the area, right? The current area. That's why let's define like helper functions here. Get area, right? And then I'm gonna call it a width here. Width uh, equals to 0, right? And mm, so one way of doing this is we can just pre-calculate all. We can try to merge all the intervals. Okay, you can try to merge all the intervals, and then in the end, with the merge intervals, we just use the length between those merge intervals, the sum of those merge intervals to calculate the area, right? And yeah, let's do that. Let's do that. So um, we need to do a merge here. Okay. Yeah, actually, so since we're going to do and a merge intervals, it's every time when we do when we add a new intervals, right? We'll do a sort, right? Sort by by the starting point, right? The we don't when we remove it, we don't need to sort it because by removing an element from a sorted intervals, it won't it will still be sorted, right? So that's why we only need to sort it when we try to add an element, right, into the sorted and then sort. And now with this sorted like intervals, we need to like do what to calculate the basically the what's the total length of the merged intervals. All right. Okay, and another way of doing this, we just simply loop through the intervals here, right? For y1, y1 and y2, right? In intervals, right? Uh, we simply check, right? We simply check the if the y2 is mm, or instead of y1, y2, let's say we call it bottom and up. How about this? Bottom and top. Maybe it's easier to understand, right? So since the interval is like it's vertical, right? So it's gonna be like this, right? For this range, and it's sorted by the from with the bottom one, with the smallest bottom uh bottom values at the beginning. Then uh, we can just simply loop through these things, right? And then while we're doing this, we can just simply uh, calculate the area, right? Calculate the length, right? The merge length. Basically, the way we're doing it, like we're gonna also uh, define a previously one so that we won't be uh we won't uh calculate the same length same segment for more than one time. Okay, so basically now every time, right, every time we have the starting point, right, basically for the current bottom and top, right, we want to check if the current bottom and top, which one it should be the starting point, right? For example, this one, let's say we calculate this one first, right? And the for the next for the following uh intervals, the starting point has to be here, right? It cannot be below this because we already if we do that, it's going to be duplicated, right? So that's why the starting point of the bottom, right, gonna be the maximum, right? The maximum of the current bottom and the previously, right? That's how we maintain this previously, right? Because every time, and now let's do it. Let's do this. And okay, and now it's time for us to calculate the current area of these intervals, right? But here we also need to do a check, right? If the top one is greater than the bottom one, right? Okay, right. So why do we need to check this? For example, this one, we have this one here, right? This is a y, and then we have another one here. So the second one is within this the first intervals, but the second one has like has a bigger bottom value, right? That's why we'll process this one first. And by the time we finish processing the first intervals, our previously will be updated with this one, with up here, right? And then when we see the second intervals, the top, since we're doing this, right? Since the every time when we start with the new intervals, we check the bottom, and we want to make sure we only intervals do an interval. This is only a valid intervals when the top is greater than the bottom. Otherwise, there's going to be a negative area here, right? That's why we do a check here, and only then we so we will be updating this previously with the top one, right? And then now we have the we'll be having the area here, right? So the area is going to be the area going to be the top minus bottom, right? Multiplied by the width. Okay, right? And for the case of like this intervals here, and then there's another intervals here, right? for the case of there's like a gap in between here, right? And then since we have this max value here, right? In this case, the max value of the previously bottom one will be smaller than the previously stored ending point will be smaller than the bottom. That's why we'll be starting from here, right? And then the top one is still greater than the bottom. That's why we will still be going inside here. And okay, so and we simply return the area here. Okay. Hmm. Okay, cool. I think that's pretty much it is, right? So sort. Okay, let's try to run it. Append. Oh, sorry. Since we're going to append a tuple here, right? We need a nested uh, parenthesis here. Okay. Bottom. Nah, bottom. Bottom. Hmm. 9 and 6. Okay. Uh, I think it's here. The previous. Yeah. We're missing a number, a character. So I'm always missing this v here when I try to define like a previous uh, variables here. So cool. And let's try to submit it. Yeah, so it passed. And actually one little thing is that one edge cases we might need to think about is the let's say there's like a two square here, like next to each other. Okay, next to each other. Hmm. Okay, and in this case, the first squares, like the square one and square two, right? So in this case, the first square's ending event will be the same, will have the same position, will be basically at the same place as the second square's starting event, right? Basically at this line here, it will have like both the end event and the start event, right? And and here, right? So when we have an end event, we will remove this x1 and y1 and y2. And in this case, the y1 and y2 are the same for s1 and s2, right? Because they have the same height, right? So in this case, the sequence might, I think the sequence matters here. If we process the end event first or the start event first. Why? Because, okay, let's think about this, right? Let's say let's say we when we reach at this point, right? Let's say we process the let's say we process the starting event of the S2 first, okay? And then we process the end event of S1. So what's gonna happen, right? So what happens will be that so if we process the S1 first, hmm, actually, well, actually it doesn't really matter, I think, in this case because I believe in Python, let's say because let's say if we process the starting point of the S2 first, and we will be append another another like y1 and y2 in this intervals. And since this is a list instead of a set, basically by that time we'll be having like a y1 and y2 and another y1 and y2, right? Basically we'll be having these two intervals in this intervals list, right? And then next we'll be processing not, we'll be processing the remove event of S1, right? I think that's how we are sorting that's how we're sorting these events now, because 0 will come before start, which is 0, will come before the end event in case the x1, x2 are the same, right? That's why we'll be processing the start event of s2 first, and then after that we'll be having two set of y1 and y2 in these intervals, and then will be the next one will be the start the end the close event or the end event of s1, and then we'll try to remove y1 and y2, right? I think this thing is it's okay because I think I believe in Python, if you do a remove here and you have multiple occurrences for this same element, it will only remove the first one. So either this one or that one, it doesn't really matter. So after this remove, we still have this intervals y1 and y2 stores in these intervals, right? But for the case, let's say there's maybe in another language or Java, I'm not sure, or C sharp, if you whenever there's like a remove, which will remove everything. Let's say if in case let's assume this will remove everything, all the currencies for y1 and y2, right? Then the sequence of this start and end event matters, right? In that case, we have to process the end event before the start event, right? Because we want to remove this one first and then we add. Otherwise, it's gonna remove everything, right? So, but in this case, but I think in Python it's fine. But I just for the sake of the of that matter of that purpose, let's try to do a little bit changes here. So for that, I'm gonna need to change the sorting a little bit here, right? So currently I'm sorting by the x and then 0 and 1, right? So all I need to do is I need to revert this kind of the second sortings here. So that's why I'm gonna do a small changes here. I'm gonna change the key from default to a lambda function here, lambda x, right? And then I'm going to use a tuple here, so it's going to be the tuple. It's going to be still the same first element, but when it comes to the second element, I'm going to instead of the default x1, I'm going to do a minus x1, right? In this case, minus 1 will come before 0, right? That's how I change the sortings a little bit, just for the sake of making sure we're not removing the starting events, right? And this should just work. Yeah, it shouldn't make any difference in our case. Okay, cool. So and yeah, very classic line sweeping or skyline problem. So real real quick. So first we'll be basically we'll be maintaining these intervals, right? But we'll be maintaining these intervals every time when we try to calculate the areas, right? So basically this is like the active intervals, and we have a start and end event, and every time when we see a start event, we uh we add this the vertical intervals, and then we sort, right? Because we want to when we calculate the areas, we need this vertical vertical intervals to be sorted. And when it is a close event, we remove, because we know, okay, now we have to remove the inactive intervals, right? And with this sorted and updated intervals, we can calculate the area every time when we add this new x, right? And the way we're doing the calculation is we uh we pass the width, right? This is pretty obvious. And then it comes down to with all those intervals, uh, we have to basically find a way of maintaining the previously calculated height, right? And then for the new ones, we have to start with whichever is higher, and then we only process it only if there's a valid area here, right? Okay, sure. And another way of doing this is we have to create like maybe a merged uh, intervals array here. So we process all those merged intervals, and then in the end we just pick all those merged intervals and we calculate the area again. But this way it's a little bit easier, I think, but it requires a little bit of careful considerations. So actually, it's for this problem that this get area method is it's more, I think to me it's more difficult than the first for loop here. Okay, so and how about the time and space complexity here, right? And so the time complexity is let's say we have n here, right? Let's say we have n events. So it's gonna be first this is n event, right? The first for loop doesn't really matter because we have a much more complicated calculation later on, so we can just simply ignore this part. So the first loop is n, right? Let's assume that n is the length of the event, and then we have a get area here, right? So inside of the n loop, we do a bunch of things. First, we do a get area. The get area is the we basically we loop through all the intervals, right? And the intervals it should be it should also be like the on time, right? Because we could have up to n intervals stores in this like intervals list, right? Basically, we're looping through all the intervals here, so it's going to be a n here, right? For this get area. And what else we do here? We also do a sort intervals. And the sort intervals is going to be what? Going to be a n log n, right? Since the n log n is it's like it's longer or bigger than the n, right? So we can simply remove this first n here, since it's bounded by whichever the time is longer, right? Basically, the time complexity is going to be the n square o n square uh, multiplied by the log n, right? That's the time complexity. How about the space complexity? Space is n basically, right? Because we have a event n here and we have a intervals here, right? So this one is n, this is also n, so 2n, which is to a on. Yeah, cool. I think that's it for this problem. Yeah. Okay. Yeah. Let me know if you guys uh, have any suggestions or questions. Yeah. And other than that, thank you so much for watching the videos and stay tuned. I'll be seeing you guys soon. Bye bye.